What is going on, guys, and welcome back to another one of the videos. Today just a really quick one. You guys can see I'm not in my usual clothes because I have to get going fairly soon. So we actually have not a theory today or something theoretical, but actually something practical today. So saw this online, of course, and I just thought, well, let's do it. So the question is, this is badly drawn right here, but I'm gonna actually put the thing on the screen so you guys can see that right around there it should be. And yeah, so let's actually have a look. So what is the question? So we have 3 circles and we need to find the area of this thing that is in, like, that is there. Now you guys might ask, okay, how do we find that? That's a great question right there. So this is just gonna be for me to visualize, right? For me to keep track of what we actually need to be doing. So I'm gonna draw this in red for you guys. All right. Well, I really tried now in red. It's kind of small, but guys, difficult for me to do this. Anyways, so let's actually have a look. So what we need to do first, or how do you guys think we're gonna approach this? Well, let's actually just maybe, I thought, do it in a way in which this is in general terms. So like we actually not define the radius as anything, but we just say that the radius is r, right? So we just say r is there, right? And so actually there's a very intelligent, or at least I would solve it in this way, right? In a very, I think, intelligent and great way. So again, this is not drawn to scale or correctly drawn, so keep in mind that this is just going to be a visual cue, but not the actual, like, not the lines are not going to be actually the size or the angle that they are in reality when you look at this thing and draw it in perfectly straight lines and all that. So yeah, so let's have a look. So first of all, what we're going to do is we're going to draw a triangle here connecting all the central points of the circles, right? So you have from a middle point here, so we just write M all throughout, just a middle point, right? So I just connected all of these, and now my first question to you guys is, this triangle here, if we draw this out, what angles and what side lengths does it have? And I think that's a great question to ask because that's actually already the solution for this problem. So we have a triangle here, which I just drew out. This is the same triangle, just drawn out here, right? A little bit bigger. And so the question is, what side lengths does it have? What angles does it have? Well, if these 3 circles are the same size, which they are, maybe it's not drawn this way, but the circles are the same size, right? Then actually side lengths are actually just 2r, which is fairly simple, isn't it? Because these things, because the radius is basically going from the middle point to all the way to the outside, right? And you just do that 2 times. So you just get 2r. Does that make sense? And because it's 3 of the same things, that means that there must be 2r here and 2r there. So this is actually an equal-sided triangle, right? Every side of this triangle is equal. Now a question to you guys, what must the angle be if we have a triangle that is equal on every side? Which side are all equal to each other? Of course 60 degrees, because we know that the sum of all angles in a triangle is 180 degrees, and they must be distributed equally, right? So we just go 180 over 3. Let's just not do that. Let's put it somewhere else. 180 over 3, which is just 60, right? 60 degrees. Good. So we know that this is an equally sided triangle, 60 degrees. Great. Well, what else do we need? Now you guys might already know where this is going. Since we have 60 degrees here, here, and here, right? What we actually must do now, it's not that difficult. What we can do is we calculate, maybe you guys see where this is going, we calculate the area of this triangle, which is very simple to do, and then we just say that we subtract 3 times the area of this segment of a circle, right? I think that makes sense, right? So basically, when you have 60, so let's just actually have a look at the segment now, right? I'll actually mark this blue. There goes another pen. I'll actually mark this blue, right? So let's maybe draw out this blue thing, right? So let's have it here. So we have this, and we have this, right? And here we have 60 degrees. And here we have 2r, and here we have 2r. That's fairly simple. Again, what is the formula for the area of a circle, which is just pi r squared, right? So we have a, which is the area of a circle, which is just pi times r squared. And the question is, how we can also do this in a different way, but let's just think about this simply, right? Easily. If we have 60 degrees, right? Alpha, let me just define this as alpha is 60 degrees. Then how many percent of the circle do we have? And we know that 60 degrees is how much of 360, right? So we just do this, 360, or we do it actually like this. 360 over 360, right? And we can actually cross this out very nicely. It just leaves 1 over 6. So we have 1 over 6 times the area of the whole circle, right? So what do we actually do with this? Well, we can say that the area for one of these small segments, right, this one, so we can actually say that the area for one of these small segments is 1 over 6 times pi r squared, right? So, but in this case we have 2r squared because no, sorry about that. It is pi r squared, sorry about that. So let's just forget that. And so we can also say we have 3 of those, so we just say area of the whole thing is 3 times 1/6, which is just 3 over 6 pi r squared. And that's just the same thing as 1/2 times pi times r squared. Great. So now we have the area of the whole triangle. Sorry. Now we have the area of these small segments here of the circle, right? All of them. This is just this formula, right? The area of this, of 3 of these, is just this formula right here. And now, what we actually need to do is very simple. Now, we just need to calculate the area of this. How do we do that? Well, I think some of you guys have learned in school, right, that you basically just do this, and then do this, and then basically you subtract the half. We can of course do that, which is no problem. Maybe there is a faster way to do this though. There is, sure. Let's maybe do it without sine, cosine, and tangent. Let's maybe have a look at it with more simple math even. Let's maybe do the Pythagoras' theorem over here, right? So let's have a look at that. So we have 2r here, and this is the side that we're looking for, right? And we have r here because this is just the half of 2r, which is just r. And so this side right here must be square root of 2r, which is just 4r squared, right, minus r squared, right? And this is actually fairly simple also. We can just say 4r squared minus r squared, which is just the same as 3r squared, right? And continuing with this is just the same as root 3 times r, right? Because the nice thing with multiplication is we can take the square root of 3 and take the square root of r squared, which is just the square root of 3 times the r, right? So actually this length is square root 3 times r, right? times r. Great. Well, what else is there to do now? Well, we said we were calculating the area of this, right? And what is the area of this? So the area is just base times height over 2, right? Because as we've all learned, we can actually divide this into 2, flip this up here, and it's just going to be the same. I'm not going to explain that right now. But we know that this height is square root 3 times r, and this is 2r, right? So we can just do that, and we can say that the area of the triangle is just the same as square root 3r times 2r over 2, right? Does that make sense? Because height, length, multiply them, and then subtract them by divide them by 2, because that is how the formula for this works. Yeah, and now what can we do? Okay, yeah, some of you guys see this. 2, cancel that out. This is just the same as square root 3 times r squared. And there we go. Simple as that, guys. Easy win. Now, all we need to do is just, again, how do we find the inner area? We just take the outer triangle and subtract this. So actually the area of our solution, so let me write this as a solution is square root 3 r squared minus 1/2 pi r squared. Now, some of you guys might even see, yeah, well, this is just r squared. So actually the way that I would write this, maybe if I were to actually write this in a nice way, is equal to r squared times square root 3 minus 1/2 times pi, and this is just the same as pi over 2. So guys, thank you for watching. That's basically it already. I mean, we are kind of cooking today, I can't lie. So of course, r squared times this doesn't change, right? R is the only variable which can actually change in this instance. So it's actually r squared times some constant. Yeah. So I could actually multiply this out, but sometimes I just like to leave it in a way in which it actually is not multiplied out, because you can plug this into the calculator exactly, and sometimes it's important to get the exact answers. I think square root of 3 is approximately 1.69 or 67. It really is that. And minus pi over 2 is of course 3.14 is like 1.57 something, right? So very small number here, but that actually makes sense because we were expecting this area here to be small anyway, because well, if you actually look at the picture that is going to be up here most of the time of this video, then you will see that it's actually quite a small area. Well, guys, thank you guys for watching. I hope this was a little bit helpful. It was just a nice demonstration of what the mathematical thing, or what math can do. Maybe I'll put up my calculator. For an area of 3 centimeters, meters, whatever, we get 1.451. So if we say r is equal to 3 centimeters, then we get a sol is equal to 1.451 square centimeters. One thing to mention, if you guys are doubting your results or doubting that you did something correct, then doubt yourself, yes, but also doubt the math. And how can you doubt the math? In a very easy way. What is the unit of the area, right? It's just centimeters or millimeters or whatever, a measurement of length squared, right? And we got that as a result. So it must be actually, I mean, it must not be correct directly, but we're on the right path. If there were a linear term here, so only r, then we would know that it is incorrect, because the area, the unit of the area is squared. Some length measurement to the power of 2, right? We know that. So, and yeah, and also there is no unit here, no unit here, so that's it. Guys, thank you so much for watching, and have a great day, and I'll see you in the next one.